This project is called Corona Discharge for Ion Mobility Spectrometry, and I will quickly explain what is ion mobility spectrometry and what does corona discharge have to do with this. So this is an ion mobility spectrometer, and this is the spectrometer actually that does the job. Everything else is just to make it work. We see here a lot of voltages. We need some voltages for the detector. These are low voltages. We need several 1000-volt voltages to make this whole approach work. And we have here a lot of tubes that are for the gas supply, because an ion mobility spectrometer is a gas detector. It is like an electronic nose. It tells you what is somewhere. This, by the way, is a setup that is almost like this in the Berlin GRU campus, GUC campus. Only at the moment it's packed in a lot of crates, and well, within the next 2 months, hopefully it will be set up so that we can use it there too. The problem is, in order to make this device use, so that I get a signal that I can use for the interpretation and identification of substances, I need to ionize the substance. And here I do this with an electron gun, but I want to replace this by so-called corona discharge, because this electron gun needs a lot of high voltages. This power supply here supplies over 8000 volt. I need here a vacuum. This is what you see here with a vacuum pump and so on. There can be better ways, especially if I want to have this all one day portable. Then I cannot have all this carrying around here with me. And then I need something smaller. And the corona discharge offers me the possibility to make this smaller. And here we see basically what it is. Somehow metal electrode with a tip, very, very sharp tip. And if you provide here then several thousand volts, then you have this discharge here. And this discharge, this visible effect, is there because this discharge creates ion in air. And these ions can then ionize whatever I want to analyze. And this is exactly my goal. So what I need to do is I need to create this one here in small. And I need to find out how to make this work properly. What voltages have to be applied, and which tip are they good? Does it all work in the small dimensions that I have only available, and so on. And this is where I will start with. Here's my needle. There's a little setup that I can later plug into my IMS device. So this is all available here at the GUC. Plus power supplies, we can easily supply up to 6500 volts. And then we just need to find out a way, how do we measure that this thing is doing what we want? Can it be current measurements? Do we see maybe over a voltage current relationship that this thing is really producing ions? Can we maybe use a detector in order to measure these ions that are then flying through the air? Is there a way? Then we would need a kind of amplifier, because the signal is probably very, very small, very weak, typically in ampere range. So we need somehow an op-amp setup that transforms then milli, or probably nano and picoampere into millivolts, so that we can probably measure it, and so on. All these solutions exist, but not here at the GUC, and this is the goal of this project. Let's get these solutions that we don't have to buy them from some other researcher or whatever. This is the goal of this project.